I think we've heard so much today, it will be almost impossible to summarise it, especially the last three presentations with the need to think at a business level. Traditionally, we have a consistent business model that we all understand for marine. If the business model is now going to be disrupted, everything else needs to be thought about differently. Obviously, I'm speaking from a class perspective. Our primary concern is the safety of the asset and of people. And everything I say will come from that perspective. I will say that it's 56 years since we first wrote control and automation class rules. And the question then is, where is the disruption? And from what I've heard today, the disruption is in the cost model. It's in assessment, which is what Malcolm covered in every aspect, is what do you look at when everything's changing, and it will change, it'll even change its programming as it works. The absolutely certain but very challenging need to assess the whole system, not the technology. The point of, much like when you have an incident, identifying human error is the starting point of the incident inquiry, not the finishing point. In the same way, the failure of the technology is the starting point of design. How does that human system, total system, work from the point of the failure of the automation? What do we then do? And that's going to be part of the huge challenge that we're going to have to face to assure these systems. And then there are the broader perspectives that we've seen today of what's the relationship between people and technology. And I think we saw little hints that certainly a few months ago we were thinking about the levels of automation, steps towards replacement of humans. What's becoming clear today is that's not the way forward. We're much looking at a harder problem of how do we assist, how do we team humans and technology in the most appropriate way that they can work most effectively. And then we come back to the fundamental question. I did like at the beginning of the day, Ivor said, it's expensive, but it works. I would argue it works because it's expensive. And we need to understand the cost model as we go forward here.
I have to say, the idea of machine learning and certification, I've not really thought about that before, and I've got to be honest, it terrifies me. So, has anyone got any bright ideas how to deal with that?
So I'm throwing on a hat I haven't worn for some time. I actually worked in AI research for 4 years in an area called case-based learning, and case-based reasoning. It is a learning system, so by definition these systems are morphing, they're evolving. So you start off with a bunch of code, and then it effectively self-evolves as it learns. I guess maybe first step in moving rapidly into the realm of the gentleman beside me, but I understand the Polar Code is the first attempt in terms of regulation where they've gone for functional definition instead of prescriptive. Maybe, I don't know, is there a way forward there where instead of saying that the rail must be 1 metre high, they're saying the rail must be high enough that a seafarer can't fall overboard. I don't know if that helps us here. But it is a huge issue because, when you get into the whole thing about formally proving a system correct, that's a snapshot in time if your system is constantly changing. So it's a real toughie. And the nature of an open system is, by definition, you can never formally prove that it will always do the right thing. And that's a big leap for people to have to take. So there's always that risk out there. And I think maybe it becomes about managing risk. You have to be sufficiently comfortable that it will do the right things in the context it's likely to encounter. But again, this becomes a qualitative argument, which is really, really challenging.
Yes, I think I wrote down somewhere before Malcolm made it difficult. The way forward that certainly IMO is hoping for, and certainly we're following class, is to go to more what we're calling goal-based rules, where you have, I think an extension of that may be a definition of the safe behaviour. So we must see a demonstration the system will achieve, will, not can, will achieve this safe state. So like the safe state for a collection of self-driving cars, if one of them gets into difficulty, is all of them parked on the hard shoulder with the flashers on, waiting to be helped. I think we need to go as far as, and that's a large problem as systems get more complex, connected, and non-deterministic. So the answer is yes, that's the direction we're moving in. There are various examples. One is, of course, for the common structural rules for tankers and bulk carriers are an attempt to go in that direction for the structure. Because we will need to include more consideration of what crews are doing, and we will no longer have the talisman of STCW, because we're talking about differently skilled for different ships, and not all on the ship. We're going to have to start to think about modelling the whole system of people and technology, not just saying, well, we think the technology's okay, so bye, someone else's problem.
There seems to be a clear sort of dichotomy here between we have a system in place which reduces the amount of manual intervention that goes on, and therefore that reduces the capability of the person to take over should it be necessary. How do we create a system where we can have the benefits of automation in terms of, autopilot is a fantastic idea, it's just cracking on across an ocean and reduces manpower. But how can we get to the point where we are, if the autopilot fails, when the autopilot fails, the person who is nominally supervising or monitoring that piece of equipment is capable of taking over? It'll be training, it'll be procedures? What's your recommendations?
Jonathan?
There's a very old paper, I think it's 1983, by a lady called Lisanne Bainbridge, that talks about the ironies of automation. And one of the ironies that she has is that when the system, which gives you reduced workload and therefore doesn't require you to basically engage in the process, you then end up being de-skilled. You're no longer able to take over when the automation goes, I don't know what to do, over to you. And you go, well, I don't know, I've not been trained. So you have and the other problem you have, I think, embedded in that, and this is where I mean going further in terms of the considerations, cost. Hopefully I've convinced you that if you buy an automated system, you have more cost in terms of training, not less. Okay? So that's a hidden cost because you don't know it until you actually receive it, and then you try and drive it and you think, oh yeah, I need to get some training on this. Or you take the risk and you go out without training. So I think one of the things I've heard all through today, and I made a comment to a colleague of mine, is that there's an irony here that we're introducing automation and advanced technologies, and we're talking more and more about the people. Because who picks it up when the automation falls over, or when the automation finds a situation it doesn't understand, or when it's receiving sensory data that doesn't allow it to solve the problem? It's the person. And whether the person's in a control room on shore, or whether they're on board the boat, doesn't really matter. It falls to someone else to do the decision making, and I think sometimes we don't think about that aspect of decision making. I wrote down a couple of phrases I quite often hear. Here's some classic ones. We've done this before, so we know what we're doing. I know, nothing to see here, move on. There's no need to examine this in situ because the equipment is standalone. In other words, just look at my bit of kit, don't worry about what's going on around it. It will never fail. Yeah, 10 to the minus 6, it's unbelievable. It's never going to happen. I was going to say something else there. It happens, right? You probably guess what I was going to say there. So I think one of the things that we have to do in terms of skill set is we have to learn how to envision the possible. What will happen and what can we do about it? We cannot glibly go over things and say, well, I don't believe that'll ever happen. That's incredible. But what if it did happen? What would be the consequence? Because these systems we're talking about are safety critical. And I think one of the other things I'm thinking about is environmental issues. Yeah, it's not long since the Torrey Canyon when we had major environmental hazards because of ships running aground. There is still a hazard there that these ships may run aground. How do we protect against that if they haven't got people on board? How do we ensure, or assure, more importantly, assure ourselves that we have a credible argument? And I think that's a very difficult question. It's not one to be answered in 5 minutes. Yeah?
So thinking in terms of the creation, automation and artificial intelligence and the creation of systems, I was thinking about the possible dangers. Cormac was talking about the human brain and that quite frequently it does it right. And this is definitely the case. But we also have biases, cognitive biases, behavioral biases. So I think an important issue is whether these automated systems are inheriting the kind of biases we have just because we create the systems. And in the case of decision-making by humans, by us, there is always some kind of moral or ethical compass that you might ex post correct an error. But once you move on to the automated level, I was wondering whether, how possible it is to have this flexibility to correct for mistakes and possible biases. I think that's an issue that will need to be addressed.
And it's a big challenge for design. The automation, the design of the automation needs to include how it fails. We can't have, we've said all day, humans are very poor at watching nothing going on until once in 10 to the minus 6 something terrible happens and then doing the right thing. Also, we're putting all this automation in place for a purpose. We're putting it in order to free up people to do other things. If it's a remote control centre, they're going to be dealing with another emergency in a different time zone, and now you're going to give them 2 emergencies. So we need to make our systems even smarter than we thought. So in other words, from my point of view, the assurance I will need to see in the future is not just that it's going to hand over to a person when it fails. I want to see a design for that there's an understanding of what that person will be capable of doing, what they will be doing at the time, what other things they're doing, as Malcolm said, and how the handover is going to be managed. Now, we're calling that in IMO, we're calling that latency. That word, that's what that word latency means. It's from the point of view at which the automation realises it's going wrong, something's going wrong, to the point at which it's not in the picture anymore and we have a situation that's under control. We need to design that as well as look at the failure. We don't stop at failure, we stop at the safe state. And that's a challenge for design. And we're not, I've never seen a safety case that covers that.
That's one of the weaknesses.
Yeah. It's the incident is not, the failure is not the beginning of the incident. It's not the end of the incident, it's the beginning. Now I think, popping into my head while we're talking about that, there seems to be a higher level need here, whether it's something IMO can take on. It's at a level of the classes of failure we might have and what we expect in the marine industry as a response. Well, that's quite deep, especially for this time of day.
Hi, Jonathan, going back to your point about latency and the opportunity, if you like, for certain things to be passed on to somebody else to free them up. Representing ship owners who perhaps sometimes will always look at the opportunity cost bottom line. If somebody believes that they have an opportunity to free up a head, they're not necessarily going to automatically think that actually they're going to use that person to do something else less tangible. They're going to actually just look at that as potential headcount saving, then they're going to take that on the basis of that being the opportunity cost for having invested in the technology. So what reassurance can you perhaps give some people in this room that actually IMO is really understanding that in the discussions on latency? Because I think for people to invest in technology, the immediate thing is they're going to look at the bottom line. And it's only going to be after it's too late, potentially, and we've had a particular serious incident, that people will then reflect and say, actually, you know, we got it wrong. We cut one too many heads here, or we did something that we shouldn't have done. But it's after the event and it's after the damage has been done. So I'm interested to know what's actually happening in the debates on that. Strikes me as somebody who's not technical that the discussions in IMO at the moment are very theoretical, and they're not actually getting down to the bottom line understanding of the nuts and bolts of what potentially could happen here. But maybe I'm wrong.
There is not yet technical discussion at IMO on these matters. We're carrying out, as Katrina very well explained, the regulatory scoping exercise just to see what will be affected. What once again popped into my mind as you were speaking was minimum safe manning. If you're going to do something very different from a normal manning, you need to present an argument as to why it's safe. And there's strict guidance on how to present that argument. As soon as we're talking about very different structures in manning, I would hope to see that FLAG understands that it needs to look very carefully at the minimum safe manning argument and declaration. And that is a goal-based thing. So I think that's our talisman, and it's a central regulation.
I think one of the other things I would say, putting a human factors head on, there are subtle things about the way that we process information that have consequences. Okay, let me give you a very simple example. Air traffic controller, planes coming in, they say, right, park yourself at the end of this runway. Goes off, does another task, comes back, another aircraft coming in, okay, come in on runway 11, whatever, okay? Brings the aircraft down on top of the other aircraft. They've forgotten, in terms of prospective memory, that they had placed the aircraft there in a hold and had then put another aircraft in on top. It's quite a common error, prospective memory, as we all do it at home. You know, we put a pot on the cooker and we think, I'll have that, and you come back and it's not boiled because you didn't go back and switch it on. That's a prospective memory error. The subtlety of the mistakes we make and the consequences they can have are poorly understood. And if you add to that situation awareness and workload, this issue of latency is not a trivial problem. So if you want to imagine switching between tasks, go to your television and just randomly switch to another channel. Try and see how long it takes you to work out what's going on, what you're watching, and what they're doing. It takes time. It all takes time. And in that time, the accident event would be unfolding. Okay?
I think something that we could learn from other industries and the different business models we have seen emerging in other industries is that there seems to be a shift from the ownership of assets towards the ownership and control of assets, towards the control of consumption patterns. So flexibility in the patterns of consumption seems to be becoming particularly important for users. And we have seen that in with the rental market, where with Zipcar you can rent a car for an hour. We have seen it in the case where jet engines are leased, and then there is after-sales service and maintenance using monitoring devices. So I think there is a clear trend towards perhaps thinking in terms of economics, where people talk about transaction cost economics and how they determine transactions. One can argue that the digitalization, the automation is changing the nature of transactions we observe in the markets and the industries, which means that it allows for more disintegrated value chains. Assets are shifted depending on ensuring some kind of flexibility in patterns of consumption. And therefore one could be expecting that trends that have taken place in other industries in the future to see kind of similar patterns in the shipping industry and the disruption of the traditional model of ship ownership and operation. And I guess this will have knock-on effects in terms of the crews and how you manage the ships and who has control over various certain processes within the value chain.
Thank you.
Just an observation on that from a maritime training and education point of view. I think that's one area of this industry where, training has been a commodity really in the maritime world for a long time. So, shipping companies go where it suits them at any given time. So if you look, for example, just at the college that I'm in now, over the last 10 years, companies come and go as their needs ebb and flow in terms of staffing and so on. Rather ironically, and counter to the point just made, we've started to see a trend in the last 5, 6, 7 years where we're starting to see companies looking for more stable arrangements. So I think maybe they're finding that there are some issues with this commodity model where moving around has a cost as well. So, and also now as I think there's a recognition that because of the added complexity that's involved now in operating these very high-tech vessels and so on, there is a need to have a more stable relationship with the training and education provider, partly because we find, for example, we're doing more and more specialised training now for specific companies for specific types of vessel, because that's how complicated they've become now. So it's kind of a counter trend maybe that's there as well. So, I guess it maybe just points to the overall fact that this whole thing is very dynamic. And, while we're talking about disruptive models in one area, we're actually seeing something of, I wouldn't call it a regression, I'd actually call it a return to maybe a better situation. So, what goes around comes around maybe.
Hello, I'm just wondering how you think training is going to change to encompass the way that people actually interact with automation, so the man-done-man teaming element or the human autonomy teaming. The remote management of vessels and stuff, if that comes, the militaries around the world have some experience of that, flying, unmanned air vehicles and stuff, and there are obviously models there which I suspect would end up with us. I think we're much further back maybe from there. The kind of questions I have right now was some of the stuff I touched on at the end of my few words, my many words, was, this whole thing that I suppose, to be blunt about it, training can't fill holes that are there because of bad design, because of stuff that hasn't been thought through properly. And we do find this, where we're in situations, and I'm not going to pick out specific examples for fear of drawing opprobrium on my head, but we do find ourselves sitting with professionals who are back for refresher training or whatever, or additional training for cadets who are coming through, and we say to them, look guys, this is actually as bad as it looks. It is broken. All we can do is tell you it's broken. Watch out for it. But there isn't actually, you can't train your way out of trouble. And certainly in terms of more cohesive ways forward in terms of our relationship, or the relationship between the people and the technology on board vessels, I think you also need to have the training and education people in there somewhere, so that at the end of it you end up with a whole system, as John has pointed out. So you'll have the technology, you'll have the relationship, the interfacing between the technology, but you'll also have figured out in some detail how that training piece, that education piece, what is in there and how it's going to be delivered. Because at the moment, in so many parts of life, not just in maritime, it's kind of thought about at the end. Right, we've built this amazing thing. Now, how are we actually going to train people to use it? And that's not really a good way to go about it. I think we all need to jump on the train now as it's leaving the station and be sure that all of those conversations are going on. I'm tempted to say if you get into full unmanned vessels, you're in a totally different space. You're training people to do something completely different. I mention video games, but there is, and the pilot who was here this morning, I think, touched on that really, really well. With the best will in the world, there's going to be a very significant detachment between what the person is doing with the joystick, sitting in a comfortable office somewhere, and whatever the ship is doing out there. That's a whole different kind of training, I think, to anything that we do at the moment.
I think Malcolm alluded to it. The need to have training in the area of understanding what's going wrong. So I don't know if it's strategic skills, but problem analysis, understanding how you make decisions, situational awareness, those as additional skills, adding on and above technical and practice skills.
The other thing I would add to that, because some people already know about this, in the aviation industry, sorry to bring them up again, but they have a system called NOTEX, which is non-technical skills as well. So if you go back to my conversation about the Savannah Express, engineer says to captain, I'm not really sure I understand the electronic systems on board. He's telling you something, and the captain did not respond to that. That's a non-technical failure. Although it's about a technical subject, it's a non-technical failure because it's about negotiating a decision-making process. And in aviation, they've put a whole wad of money into that. They've reapplied it in surgical skills, in operating theatres as well. I see no reason why it shouldn't be applied within the maritime environment. In fact, I suspect I already know that there are some people doing that.
It's an augmentation of bridge resource management.
Yeah.
It's putting, when SAS and Swedish Icebreakers put together the original bridge resource management training, they included the equipment as a resource. That normally gets taken out of training, but it's actually an essential element and will become even more so, especially when you're coordinating some kind of remote support centre, which may be providing you technical knowledge rather than strategic knowledge and what you're trying to do on the ship.
Yeah. One added thing I would say to that, people imagine that non-technical skills, quite often in hard-nosed engineering environments, are kind of fluffy and woolly. What you have to do, and a colleague of mine does this with helicopters in the North Sea, you put people in a simulator, you give them a technical challenge, but you also look and mark and score their non-technical skills. In other words, you have an engine failure, what you're going to do about it, which rig are you going to divert to and land on, and so on and so forth. You stress them in terms of the technical skill, but you also look at the non-technical way they negotiate, engage, decide, and act. And that's really important, because if you look at the example of the Savannah Express, there was a hold point there where you should have said, no, don't go any further until we got this sorted out. And they went beyond that point, and that was a sort of decision-making error.
Hello, Bob Home, Plymouth University. One of the things we keep hearing about, of course, is training. And I'm quite sort of passionate about education. And I think it's important that the cadets, they go through and they do their foundation degrees, but also then they get the opportunity to do a BSc. And at Plymouth, we're actually doing a master's degree now in automation systems, where the students are educated with sensor management, artificial intelligence, big data. So we have mariners who actually have the education and the knowledge and the practical experience to take that through to the workplace. And I think we can train people to do whatever, but we need to have educated people working on board ships who can actually think outside the box and to make decisions and direct the future training. So education, I think, is more important than training.
Thank you for saying so. Look, it's a huge piece. We're in a world now where all of the students who come through are being dual qualified. They're being dual qualified because on the one side, the students, their parents and guardians, want them to have an academic qualification for their longer term career. And obviously on the other side, the shipping companies, etc., want them to have their professional qualification. Both are absolutely necessary. They're not inseparable any longer. They haven't been for a long time. If I had to take off my sort of official head of college hat and offer a personal perspective here, I think maybe we have fallen too far on the side of training over education in the last decade, and it has not served us well. And the cracks are beginning to show exactly, I think, as you're pointing to there. You know, we've in our rush to get people qualified and to get them out there, we're teaching them knobology. We're not giving them the fundamental skills underneath that allow them do things like effective problem solving, critical analysis, be it logical or numerical, and so on. And I'll be honest with you, it's been on my mind for a while now. I think maybe we need to open up the conversation about the fact that we need to be keeping seafarers in college for an extra year, because they need more education to balance the training they're getting, which is fine for, you know, turning things on and off and all the rest of it. But there's a whole other piece here which I think has kind of fallen away. And it is a problem. It's becoming a big, big problem, I think, now, and it's only going to get more of an issue, I think, in the coming years. So
absolutely, yep, I'm with you on that one.
Now, while I perfectly agree with the gentleman talking about the education and with your viewpoint, on a practical level, the issue is how do you get the individual to retain the knowledge, the education that he gets? Because when he is in the real world, for months and years, he never utilizes anything of that education that we had. So, I mean, taking back to our days, running fixes, horizontal sextant angles, vertical sextant angles, never ever use them out at sea, right? And today with the increased automation that we are getting, if a person has never seen a GPS failure in his entire life, or even if he has, there are 4 GPSs on an average ship today and a GLONASS, how do we convince him to spend that extra year in education? And even if we do, meaning the company pays for it and NC goes, even then, how do we get him to retain that knowledge? What are your thoughts on that?
I suppose lifelong learning is part of the answer. I'm actually sitting here looking at you going, maybe part of the answer is how we encourage people to spend their spare time at sea, which means they've got to have spare time at sea. I look back even to when I was there, which was late 80s and around that time. You know, maybe part of the answer to that question lies both in the realms of the seafarer health and well-being discussion about how people would choose to use their spare time. Professional pride is an element of it, I think. Interestingly, perhaps this question we have about, you know, this ability to re-engage immediately when something goes wrong. You know, this how do you maintain situational awareness so that you can immediately step in if something goes wrong? Something we've been talking a lot about is, in the course of a normal 4-hour watch, for example, is there things people can be doing which help them to practice for that eventuality? And you know, so that might be, for example, if you have, you know, two officers of the watch on a particular vessel, that 3 times an hour they'd throw a random failure situation at the other, and the other has to go bang, 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 bang. This is what I would do. This is how I would do it. You know, do all the elements of it that you can. It's a very, very important question you've asked. I don't have the answers to it, but I think we would need to find the answers to it because it is a big part of it, yeah. Skills are lost if they're not used. Education gets forgotten about if it's not regularly refreshed. So, yeah, there's a big question there.
Thank you. Gentlemen, thank you very much.